What is up, my friends and family? I know it has been quite a minute since I was on the stream. Lots of things happen. I now have dead guy corneas, which is fun, at least about 20% worth. And that was a nightmare. I do not wish eye surgery on my worst enemy. But I am back at it, at least for a couple hours a day while I am on leave recovering from that surgery. And I'm taking this opportunity to max out all of my side projects, all of my hobbies, and really lock in and get some stuff done. So first, number one priority was open sauce. That submission has been shipped off, and I haven't heard anything. I don't think we're going to make it to open sauce this year, honestly, and that's okay. It's just what had to happen. So choices were made, and I chose to have my eyes worked on. Anyway, we are, in fact, moving on to our next highest priority, and now the top priority is this Formula One wing, which I've already printed out a full-scale version of, at least in sections, just for test fitting, and made some changes, made some alterations, and it's looking really good. I talked with Dylan, and he's excited about it. The event that we proposed for the debut of this didn't end up happening, but that's okay because we added a feature that wasn't in the original design concept, and he said he wanted that he wanted that to be, he would allow the deadline to pass if we could implement that feature. So a little bit of a grace period there. He's actually at that event right now. Anyway, so I don't know where we left off last time, honestly. I'm not really sure. But let's go ahead and get it where you can see what I'm looking at. So in the lower section, we split the main feature into these zigzags, and the reason we do that is so that when we stack them all, skewer them all together like a kebab, there's less risk of those pieces racking against each other. It also, as you tighten it, the pieces, we have that keystone section there, so they're kind of forced into each other tighter and tighter, which again just makes the structure more rigid. So what you got going on is a recessed threaded rod that goes all the way through. Let's go ahead and make this translucent here. So you've got the this rod runs from one side to the other, and on both sides you have a nut, and as you tighten that, like I said, it draws the whole thing together like a sandwich. But to give it some more rigidity and also prevent that racking a little bit further, we've got a front main beam, which is aluminum tubing, 3/4 inch diameter, and a rear skewer, which is just a 1/4 inch aluminum rod. And in the test fit, all of this, when you do that, boom, one piece, you don't even need any glue. That thing is strong as heck. So one concern I do have is when we switch to the carbon fiber reinforced materials, a lot of times those suffer from dimensional stability, dimensional accuracy, I would say, maybe. So a lot of the tolerances that I've done here for PLA may not apply to the PETG carbon fiber. But so Dylan is actually getting, the reason he messaged me recently is he was getting a sponsorship from Bamboo Labs. They're going to send him a machine and the filament to print this project. So I was just going to send him the 3D files and the non-printed parts. But I think what I am actually going to do is completely manufacture the entire spoiler here. Then he can use my parts or not, in case what he prints doesn't perfectly align with my tolerances. That way we're not having to do all this back and forth. He doesn't waste a lot of material printing up there in Colorado, and it doesn't fit. So let's talk about some design features. We obviously have to hold the spoiler to the side of the side plates to the spoiler somehow, and that's where these nuts come in. While you're assembling this, you drop a nut down there, you thread a bolt in from the end here, and as you tighten it, it locks itself into place. So you'll notice these tubes, which are just hollow points, and that is because without them, let's see if I can get bamboo. Without them, there's no infill in this compression between this face and the face of that nut. So you can imagine that each one of those tubes is just a column. So when you tighten that nut, it's gonna squish up on those columns instead of just tearing through the infill. And I've done the same thing for the main beam here, and that works really well. It's very strong. So yeah, that's the lower beam, pretty well finished, the lower cross member here. And so I have all these materials on hand. Oops, I was supposed to go to the hardware store. I pre-ordered some, paid for them already. But yeah, I have all these materials on hand, so we're not waiting on anything. I even have the 3D filament on hand to manufacture it, and he sent me the side plates, so we're gonna rock and roll here. So let's recap a little bit. These two plates are gonna get welded to the chassis of the vehicle. They're steel. Then he can bolt the spoiler onto those plates. He can space it out however he needs to, and then with the center pivot here and the slots, he can adjust the entire angle of the spoiler. It'll pivot about this center section here, and that way he can level it out. So I'm pretty content with the bottom member here, and I think today I know how much fun it would be to go ahead and start tackling the DRS, but I think for right now in this moment I'm going to go ahead and just copy the features that make this bottom assembly complete, and start working on making this top one. And that is because I have a lot happened between when I knew what I was doing and now, and I need to just get back in this and start on it. And I think that'll be a good motivation to see this top one done. So without further ado, let me make a couple changes here real quick to some things in the back seat, and I will be right back. So it is hot in the house, very hot. That's what I love about smart thermostats. Bumping that AC on right now from my telephone. Dunzos. And then we're gonna hop over here. Okay, dope. So let's hop into our upper cross member. So features we know we need throughout the whole thing are gonna be, where's our sketch? So I know I have the 750 threaded rod. I have the 5/16, sorry, the 750 smooth rod tube. I have the 5/16 threaded rod, and I have the 1/4 inch rod, and we want all the same dimensions from this one. So 775, 3375. On the, so it's really weird. Actually, now that I think about it, it makes total sense. But as soon as I pulled the print off the printer, it didn't fit over the rods. And then I went and checked it a couple days later, and the threaded rods went right through. So that just goes to show you that thermal expansion is real. Okay, so those dudes go all the way through the entire assembly. And we want this thing centered up between the upper and lower profiles. Maybe you don't want it to touch that one. Oh, you know what? We should do the same wall thickness as the other one, which is 125. Perfect. And we'll do the same on the rear. I don't know what we did with that or why we did it like that. Oh, because I made it a straight line. Okay. Wait. We had a constraint. We had another constraint, which was the size of the washer here, which is 750. Okay, we're gonna be fine on that. Uh-oh, SolidWorks locked up. Give me a sec, SolidWorks, please. Please don't cry. Please don't crash. Okay, perfect. So these features will go all the way through. Dunzos. So next we should add the features for the bolts, which, if I remember correctly, we may run into some challenges because the nuts. I don't know if adding the nuts into this is the strongest way to do it. Probably isn't, but for what it is very strong. And most of the feature, or most of the forces in this, are going to be in the in a compressive plane. Let's see if we can move. think about that for a second. So what I want to do, this will have a bolt right at the front edge, but I want that tubing, that cross member, to be as close to the front as possible. So we're gonna actually go back in and edit that again. Uh-oh. Broke SolidWorks again. Give me 1 sec while everything's froze up. I'm checking my resources. Okay. I probably just need to close the assembly, and that way I won't make this mistake again. One moment, please. Cool. Okay. I think we're back. Just changed a couple things. Okay, that's fun. Got my first chat in like a million years. Appreciate it. Tactical printing. Not sure what I'm doing that would interest you. I hope that you're having a good time. Well, I guess I'm printing some, so. Anyway, very fun. Let's see about this. Okay, so now that those are all defined, that's defined. Let's make that, boom. Okay. And so we'll hop back over to the other one so we get our offsets from that. So the offset was here. Boom. We'll just steal that because it worked last time. This is the part that I've test printed, so I'm very confident in this. Working for the, if it works for the lower cross member, it's gonna work for the upper one. So go ahead and cut that, dude. We'll do an offset, boom, from the sketch plane. And it's always the wrong way because SolidWorks rocks like that. And then I forget how long it was, but we'll just make it 1/2 inch for just a second. We'll hop back in over here. Nice. Well, I hope you find something you like. Mostly I've just been doing live streams on here. I do crazy projects all the time. If you check out the rest of the channel, you'll see some really old robotic stuff that I did. Well, I guess props. But I've been doing crazy things my whole life. Decided to pick up the camera, put it on. I would be doing the same thing if the camera wasn't there. I'd be on CAD, you know, doing whatever it is that this is. So I'm just hoping that somebody finds it entertaining, or I don't know. Yeah, maybe somebody finds it entertaining. So we only did a 1/4 inch offset of that. Okay, so that makes the hexagonal part 1/4 inch. Okay. We're gonna use that sketch that we started here. Oh, and then that was a custom hole size too. So that 6mm hole is actually 6.5 if I remember correctly. Yes. I'm sure there's a way to port over all of this as like one drag and drop feature, like in sheet metal. You could make a sheet metal feature that you could just drag and drop to whatever you're doing, but don't know how to do that right away, and so I will learn that in the future. Okay, so that gives us our nuts. Let's go ahead and get our, what's the diameter of this circle here? .45. So we could actually start this sketch from wherever the hex stops, which you might be able to see through here. Yeah, boom. So we'll do an extrude cut on that. We'll have our, these will be equal. I need to check out what tactical printing is real quick. That has got me so curious. Nice. Okay. So we've got all the features that will hold the part to the fin, or for the fin to the part. We've got our tube. We've got our, oh no, we need to build our pocket for our threaded rod. So this guy, it's 0.75, and the depth on that is 0.5. So we'll go 3/4 on that, just like the last one. And only 1/2 inch deep, does that make sense? I guess so, yeah, that looks right. Okay, let's save that real quick. I want these tubes running through the whole part again. So there's 8 of them, and they're 0.875. So circular patterns have always confused me, because for most everything else you can click the 2 things that you want to do and SolidWorks figures it out, like what you're, see, look at that. Why is it's pinning, it's trying to go around the origin over here. But like in a mate situation, it would know exactly that I wanted one of those to mate to the other one. So it's just one of those things, I don't know why it's different than the rest of, even in other types of the same feature, if I click 2 entities, it knows one is the parent, one's the child. So that's weird. Okay, and then we need the tubes for the compression around. Around the spoiler nuts, or the winglets, whatever you want to call them, the side plates. So that is this one, and that is 0.0375. So what we're doing, earlier I mentioned that when you have that nut embedded in the part and you tighten against it, if it's just normal infill, it's going to pull right through. So what we do is add an internal column. So as you tighten that nut, it's going to compress these columns instead of tearing through the infill. So every couple seconds, or a couple minutes, I'm gonna have to hop over here and read some more things. I'm trying to multitask here. Get rid of that. See, it did it again. Well, it did it, or I did it. I did it. Boom, there's that. And then, oh, it's not 5, it's 6. Obviously. And then there's a specific offset here that we're using for these columns, and that is the thickness that we're going to print, so that it doesn't have any holes or voids. So we start this, and that way the column floats internally to the part, but it's in contact with the top layer and the bottom layer. So I don't know if that makes sense. I'll show you when we go to slice it. Perfect. Okay, so what's going to happen when it's actually 3D printing, the very first couple of layers will be solid, and then it'll start these columns. There will be no gap between the column and the wall, the top surface. So, and the same up here. So when it compresses, there's no void. That's why we do that offset there. So we're gonna copy this entire situation over to our other nut. But for whatever reason, we're just gonna have to redraw it. But we don't have to dimension this, so we can just make it equal. We will have to pattern it. Dunzo, and it'll have the same it'll have the same offsets because we have the same it's within the same cut profile. So I think this is an 050 chamfer we have on all those things. Yep. So okay, the next thing we need to look at is, and I did these parts a little differently than I'm not doing the bolt holes. Should I do the bolt holes? I'm not doing the bolt holes. I did this part a little differently than I did the lower one. So I created all the end features first, and now I'm gonna go slice it up and then figure them out for the center post. Because I mirrored really early on in the part, and if you're making a part that's symmetrical and you only want to have to do work to one half of it, then mirroring is one of the last things you want to do in the process. That way it captures all the work that you did. And so now I can go and cut and all this stuff, just do a cut right down the center of this part, mirror it over, and all my features will be on both halves. Where on the bottom side, you can see that a lot of, well, initially a lot of the parts were, there's two mirrors going on here. You know what I mean? And in the other one, I'll just have one. It was a pain in the butt. I don't know if that makes any sense. So we're going to save this lower cross member again. We're Dunzo's here. We're going to go back into here. Now we've got these features going on, and we have this guy, this boy, this gentleman. Ooh, yeah, he's doing pretty good, cutting through all this stuff. So it'll get the rod here and the center main bolt there. Let me think about this for a second. Let me think about this. Okay. So Okay. So we're attaching it in the center here. We're supporting it in the center. The weight of the spoiler is definitely on this lower member. Which is going to be okay, I think. Should we have this slot through there? Would that be... Would that be strong? Okay, I think I'm back in the swing. I think I'm feeling good about it. So let's hop over, instead of messing with splitting this up like we did the lower one so it's printable, let's actually start looking at the DRS. So the thought that I had is that these vanes were fixed on the front edge, and then there was the actuator moved them from the back edge, so just pull them down flat and with some sort of linkage. So what we need to do, we need to how are these mated? We want pretty much all of that gone. Let's add a hole to this. So that a pivot point, you know. I have a bunch of 1/4 inch rods. Ugh, that's pretty big. Maybe I need that to be, what's 10? 1875, right? 10 mil? Or I mean, number 10. So we'll use a number 10 on this one. Okay, so we'll throw this an extrude cut all the way through, and this will be our pivot point. Okay, I need to take a quickie break real quick. Okay, whoopies. That wasn't what I wanted it to be. Trying to get a lot of things done all at once. So part of the recovery for my eye surgery is I have to take eye drops 4 times a day, 2 different kinds. And one of them is like putting milk in your eye. It is, neither of them hurt, neither of them burn or anything, but for a solid 5 or 10 minutes, I can't see. So I had to give that a little bit of a go. And then I ran out, and so just placed the order for those. So here we go, back to the grind. So the idea is this is fixed somewhere down here. We'll make like a fairing to go around it, obviously, but it's just gonna pull on the back of these guys, and I really like the positioning of them, so we're gonna edit the cross member to support them. Oh no. Okay, so we're trying to make this a little bit less intense. Okay, that's probably gonna throw a lot of stuff off, so. Oh, not too bad. Let's move. What happened? I think I deleted this. Whoopies. Okay. Yeah, I made a mistake. I deleted the side plate. Jack from Jack in the Shop. I am building a Formula 1 car spoiler or wing for the YouTube channel. Oops. For the channel, The Rad Factory. Okay. Amateur hour over here. Yeah, so the Rad Factory bought a cheap Formula 2000, or I forget what he calls it, but it's a fake Formula 1 car, right? And I met these guys at the SEMA show when I brought my Datsun B210 up there. And I have to be a part of whatever they're doing because their channel's just so nuts. So I messaged him on Instagram and said, hey, you probably don't remember me, but we met at the SEMA show, and I would love to design an actual spoiler for your race car, because he was complaining about how home built some parts of that thing were, and I have an actual engineering background. So we got to talking. He sent me some reference photos, and then one of the things that he actually wants really bad is DRS, which is the drag reduction system. So when you hit a button on a straightaway, the top two fins of this spoiler are going to flatten out and reduce the amount of drag that this creates. So we're 3D printing this at home, carbon fiber PLA, PTG, carbon fiber PETG. And the side plates I'll cut on my CNC machine. The aluminum and steel parts I'll get from Send-Cut Send. And then I'm going to design a GPS controlled box that he can put in the car, so he can adjust the speed, but at a certain speed, without being distracted by having to remember to turn this off and on. It'll do it automatically. So that's something that I haven't told him, but I'm well, on my other project, I'm building a 1/77 scale deep space antenna, and it uses GPS to track its own position and location, and then track satellites. And so I've been messing with ESP32 and GPS. So right now I've already printed out this whole lower crossmember assembly. It bolts together with a lead screw that goes all the way down the whole assembly. Let me make that translucent here. And that sandwiches it, and then the trapezoid sections let it lock into place so it's really rigid, it doesn't twist. And I have a piece of aluminum and an aluminum bar at the back. Then we're holding the side plates on with these M6 countersunk screws. And we just finished adding all of the features, the tube and the bolting features, to this upper crossmember. They are not the same. And now what I'm trying to do is add enough features to this center plate so that I can start messing with the linkage that's going to lay these back. So we were able to, I kind of broke the assembly there for a second I deleted one of the plates by mistake, and then SolidWorks only lets you undo a specific number of things before you can't anymore. And unfortunately I had to rebuild a little bit of the assembly, but we're just going to add a sketch. We're going to constrain off a sketch on this while we figure out some other features. So yeah, I'm having a lot of fun making this. I took a bit of a break because I had my corneas replaced or augmented or whatever, and that was a mess. But we don't want external references on this. We want these points to be what define where the slats are. So initially we just drug them to where they're at, but now we'll constrain them to the sketch. And if we constrain them to a sketch that is constrained itself by the location of those slats, it'll create circular logic, and we will have a nightmare situation on our hands. So now we should be able to use that sketch to hinge these parts. And when we actuate the actuator, it should pull down on... that thing needs to not move. So we'll go ahead and fix it. Boom. But when we pull down on these, they should flatten out like this. And that's in the high speed, high straightaway areas. The air will pass through it, and these are exactly what they look like. They're upside down airfoils. So as the high speed air is forced over the wing, it sucks the profile down, and those are actually calculated. I used a model builder online for that, so there's math behind those. These ones too, they have an actual airfoil profile. So in normal operation, when he's cruising around, you want the maximum downforce, so going around corners and stuff. This creates a this is probably a little too far up. This creates a really aggressive path for the air to flow, and it provides a lot of downforce. But like I said, when he hits a certain speed in a straightaway, he wants these things to fold down flat. So let's start talking about what that's going to look like. Of course, the first idea is a linkage between the two, and that is just then pulled on by the bottom. So how many degrees do I need that to work? We're going to take a measurement off the plane of the top one, and if we look down here in the bottom right, usually it tells us what that angle is, but apparently not today, so we're going to use the measure tool. We'll measure. Why am I not getting that measurement? It looks like 50 degrees. $60. So that rear one needs to go from 0 to 60, and the top one, what does that look like? 45. Yeah, probably 40 degrees. So that looks to be 30 degrees. So we need to move something at 30 degrees, and we need to move something at 60 degrees with the same actuator, which to me says that we're gonna have to have two different linkages. But oh man, there was this program somebody put on a YouTube short one time, and the concept was you could put in 2 points that you need to move in a certain area, and it would generate a linkage that would do that. I wonder if I can remember that. But for now, let's go ahead and we're gonna do a mate constraint on this so that we don't have to worry about it. So what we can do is we can say at the maximum you're gonna be 30 degrees away from parallel, and at the minimum you're gonna be at parallel. And since we constrained it to the sketch within this the sketch that is within this boomerang part, it's essentially like putting a bolt through that boomerang part that is the pivot point for this. So now we say it can only move from 30 to 0, which I'm a fan of, and we'll do the same here on this top one. So we can take that top slat, those two top planes, oops, if we click the two top planes and then use the little pop-up menu, the maximum way it can be is 60 degrees, and the minimum will be 0 degrees. So what that again is going to let us do is when we move this, it'll lay flat. Boom. And otherwise it will move all the way to its max extent. So now all we got to do is figure, how do we pull on these at two different, unless the pulling happens closer to the pivot point, then we could use one linkage. So further out from the pivot point, it's going to move less, so we'll have to move the pivot off this one closer. And a lot of this is trial and error for me. Let's see if we can find that program. Give me 1 second, I'm gonna look for it. Optimus Modus. I think I found it. Yeah, I don't want to learn how to use that right now. So we're gonna look at let's do a linear pattern of some holes here, which will give us some it'll give us some mounting options. So we're just gonna do like a funky little sketch here. Maybe we could do pattern along a curve, and that would be really clever. You think I can do that? Ugh. So the parameter is going to be that point, and we're going to pivot our entity here. We're not going to do 360. We're going to do angular spacing. We're going to have them spaced at 10-degree intervals. Or 10 is too much. So now if we do that, we have 4 little options for to pick up on our linkage. So if we want to move a lot, we put it up towards this front linkage or front hole. If we want to move it a little bit, we can move it further towards the back. So let's see what that does. I'm gonna save it. I need to save things a lot more often. One of the problems I had, which kind of threw off, excuse me, kind of threw off my groove was, I did everything right. I saved, I closed the program down soft, and I came back a couple days later, booted it up, and a whole bunch of my progress was gone. And something with the way that SolidWorks talks to the servers, I guess, it pulled the wrong version of my file, and I had to go back through and redo a lot of work. Thankfully, I remembered that my backups were turned on, and I went back into that area, pulled it, and it was still out of date, but it was a lot closer. But yeah, I don't know why. I shut it down correctly, and there wasn't a crash or anything. Went back several days later, and my model was an old version, which was super, super annoying. So let's see what the distance between these 2 points is. Is my measuring tool just not going to work for me? What's that? 3 5/8. So let's make a new part here. This is, we're just testing shapes, and then we'll make things, we'll optimize for printing, and we'll optimize for aesthetics, because what's a good design if it doesn't look good? So I don't know, we don't even need that actually. I don't like blue sketches even while we're doing this, so we'll go ahead and just make that, and then we'll call this the DRS linkage. How's that? Does that work for everybody? If somebody who's watching knows anything about this racing series, could you please enlighten me? This is a 4-cylinder Ford engine. Is this a do they do this still? Is this still around? Okay, so we're gonna use a 1/8" aluminum, probably. That's the goal here, at least. We'll insert our DRS linkage, boom. And I don't care that it's existing in space that other parts are also existing in right now. like I said, we're trying to see the motion here. Did I do 3 5/8 or did I do? This should be a bell crank. We should do this. We should do this with little Heim joints. That would be so much better. Okay, sick. So check this out. This may be way too aggressive, but oh, maybe not. We're getting close. Look at that. So the bottom one moves to level. We need to move it up just a hair. Look at that. Oh, that's cool. That is super cool. Yeah. So how do we do that? It's not moving. The top one's not moving vertical enough, and it's not moving horizontal enough, so it doesn't have enough range of motion. So that means we need to adjust this sketch. Let's position this permanently ish. Okay, I guess this is gonna be number 10 hardware as well. Dang, this thing's tiny. So she's not happy about that mate anymore. Let's go ahead and measure. Okay, we're about to test this out. I think it's gonna work. Wait, what happened? $3.57. Okay. Okay, hang with me. You're gonna want to see this. There we go. Okay, check this out. Boom. And then with a flip of a switch. Boom. Okay, it's not moving enough still. What if we move it up to the second hole? That is 3 inches. If we make this a turnbuckle, then this is adjustable too. Everything can just be adjustable as heck. Whoa. The 3.3. Is that what I just read? I'm just being dumb. 3.3. My eyes are still not amazing. Okay, so let's move this closer so SolidWorks doesn't cry about it. And we mate these two. Okay. Boom. That's all the way up. And man, that's still not moving that guy hardly enough. We need to move it in some more. Or do we need to move the bottom one forward one? Oh, I have this backwards. I have this totally backwards. Watch. I bet it works first try. I bet this works first try. Check this out. You're about to see me get really excited. I've had this in my head for weeks, you know. Hmm. 2 3/8 wasn't the move, but we're getting so much closer. .375. So why didn't it like that? Okay, that's about all my back can handle for right now in this chair, so I'm going to have to get up and do some laps around the house, but I will be back later this afternoon to continue working on this. So if you're interested in this project, like and subscribe to my channel, and you will get to see us completely fabricate a Formula 1 spoiler with active DRS from home in the home garage. So appreciate you, everybody that did stop by today. Those of you that left comments, thanks for tuning in, and we'll be back again soon, I'm sure. Thank you very much.